Okay, this classwork video is for any of you who did not get a 100% on version number 2, whether it be a retake or just classwork. I'm going to have you do the work, check your work on mine, write what I write, and then write down the 5 words to show me that you listened. This first one here, to get this one right, you had to take point E, which is this one right here, and know that that coordinate is the coordinate 1 for x, 2 for y. If I do a 90-degree quarter turn to the right, that's clockwise. I'm going to take that point, flip it, and then make that right one the opposite. So flip it around first, and then look at that right one and make that right one opposite. If I was to do a quarter turn to the left instead, I would take that same point, flip it, but then after flipping it, I would make that left one negative. So negative 2, 1 would be E prime if I did quarter turn to the left. Make sure you're writing this. If I was to do E prime doing a quarter turn to the right, that would be 2, negative 1. End up right here. 2, negative 1. That would be this one right here. That would be B. All the other ones are close, but not quite flipping it and making that right one opposite. And then your explanations, pick one of the incorrect ones and say that, like, maybe choice C is incorrect because they're both flipped and they're both made opposite. That's a common mistake people make. Or this one right here where they don't flip it and just make one of them opposite, if you want to talk about that. First word is black. Black. All right, this one right here, you had to see that 105 and this unknown angle right here, they add up to be 180. So if I know that that angle 105 and the one next to it equal 180, all I have to do is take 180, take away that 105, and that will give me what that missing angle has to be. Because remember, they have to add up to 180. So if I know half of it is 105, take that away from 180, gives me 75. That angle has to be 75 because 75 and 105 give me 180. Now, to find this outside angle, all I have to do is add these two inside angles not close to that. So take that 41, take that 75, add them together, and that will give me what that outside angle would have to be. This one, it is 116 degrees. And for your explanation, a complete sentence talking about taking away 105 from 180 first, and then adding the two interior angles to get that exterior. This is called, write this on your paper, this is the exterior angle. Any exterior angles made up of two angles on the inside, draw this too. Any triangle, any outside angle is made up of the two inside angles added up. So maybe 20, maybe make this 90. If I wanted to find that x, all I have to do is add up those two inside angles. That gives me what this angle would have to be, 110. And that makes sense because if this is 110, this angle right here has to be whatever it takes to add to 110 to get 180, or has to add to these two to get that missing piece be 180. But no matter what, that y you could see would have to be 80 degrees right there for that angle, because 80 plus 110 gives me 180. I'm sorry, that wouldn't be 80. I think that would be 70. Let's change that. There we go. Because if that's 70, these two add up to be 180. These three add up to be 180. All right, here we go. Next problem, and then the second word coming at you. All right, for this one, I had you compare DF to D prime F prime, and those are clearly the same length. I had you compare angle D to angle D prime, clearly equal. And then I had you compare angle F, which is this square angle, compared to angle D prime, and I could see angle F is bigger. That square angle F is bigger than that little slanted angle D. So that is true. All three of those are true. For this one, if I reflect over this line right here, I need to know that all my angles on either side of that are the equal ones. So that's an equal pair right there. These two are equal. These two up here, those are equal. These two right here, those two are equal. You need to know that. So I'm looking for my answer down there that has a pair that's equal. H and A, that looks like right away. I have a pair right away, this H and that A. E and A would be no good. F and B, no good. Close, but no good. F is equal to C, but not B. And then H and D, no good. Second word is tan. Tan. All right, here we go. Next. For this one, since there's no boxes, you're just pretty much charting the movement, but no, you're starting here because that's the first triangle and you're ending right here. So got to make sure, looking at those numbers, it starts at 1 and then it goes to 2, then it ends at 3. So if I'm going from 1 to 2, triangle is just sliding, just moving, just translating, not changing its direction, its rotation, translating. So translating left, that's a translate left. Just moving to the left, the whole triangle. And then I can see, then I'm doing a flip. I'm doing a mirror image over that x-axis line right there. This is the x-axis. So that is a translate left and then reflect over the x-axis, not the y-axis, x-axis. And you can see the only one that works right there is translate left, reflect over the x-axis. This one's close, but it says reflect over y. This one says translate right, which you're moving over here, and that's not what I did. And then if I reflect over the x-axis first, it will look like this. But then if I move that to the right, that ends up over here. So that one wouldn't work. If I had reflect over x and then translate left, that one would have been a good answer right there. But I did not have that. Had you translate right, made that a bad choice. All right, here we go. Next problem. Next word. All right, for this, a 180, you got to know, always ends up going straight across, or a half turn, you always end up in the quadrant straight across. That's going to end up upside down. You get those coordinates by just taking the originals and then not flipping them. You're not doing rotation. Those quarter turns have you flip the coordinates and make one of them negative. For this one, doing a half turn, the coordinates do not flip. They just become the opposite of what they were, and that will always give you that upside down look to it being the opposite. I believe that's 7-2. If I do the upside down one, I'm just oppositing those. So that becomes -2, -2. E prime becomes -3, -4. Notice I'm not switching them. That's only for quarter turns do I flip the points around. These, I'm leaving them in their position, but just oppositing them. And if you plot that, that will always get that upside down look. that happens when you do one of these. So negative 7, 2 would be right here. And then these parts right here. That's going to be E prime right here. It's going to be F prime right here. So that is my trapezoid doing a half turn where my coordinates flip upside down. They become opposite. Third word is yellow. Yellow. All right, for this one, most people, they did a reflection over this y-axis first, because if you reflect it over that y-axis first, then you can see from there down to this corner, you just got to count boxes. 1, 2, 3, 4, 5, 6. So it looks like for this one, I would choose to do a reflect over the y-axis first. Then translate. And then for this one with boxes, got to be precise with your numbers. Down 6. This problem without boxes, you just got to give general directions. But this one with boxes, you got to be precise. Reflect over the y-axis, translate down 6. Some people will choose to translate it down 6 first and then reflect over the y-axis. That is perfectly fine. Full credit if you were to choose to do it that way. All right, here we go. Almost done. For this one, here we go. For these, the angles straight across, those are called vertical angles. Vertical angles are always equal. If I look at other angles that are equal, though, I got these corresponding angles. Corresponding angles equal. Alternate interior angles are equal. You could see, or trust your eyeball. Your eyeball sees those openings. The other type, though, other than vertical being straight across from each other, or congruent, which are equal, the other type are supplementary, the ones that add up to 180. Same side interior add up to 180. If I do straight angles or angles right next to each other, those add up to 180 also. So know that. So here I go. When I do this, first one says angle A and B are congruent, but those are right next to each other. Those add up to be 180, so those are not equal for this diagram. Angle B and C, ooh, again, those are not equal. Those add up to 180, however, those inside angles, but not equal. All right, next. Let's cross that out. All right, next one says C and H are vertical. Yep, straight across. F and H are congruent. So let's circle that one. F right here, H right there. My eyeball clearly sees. Those are called corresponding angles. One on the inside, one on the outside. Corresponding, equal. And then the last one, B and G. Ooh, yes, those are alternate interior angles equal. So remember, angles A and B, those are not congruent. They're supplementary. They add up to 180. Same with B and C. They add up to 180. But all the rest, vertical angles, equal. H and F, corresponding angles, equal. Alternate interior angles, equal. All right, here we go. This one. I want you to see that this one is a corresponding angle to this. If I know 57's right there, I know that the corresponding angle, or trust your eyeball, this is 57. So right away I know angle B is 57 degrees. To find angle A, I just know that these two add up to 180. If I take 180, take away that 57, it gives me what's left to get that 180 if I was to add it. So if I take away that 57, gives me the angle of 123, because 123 and 57 add up to be 180. All right, fourth word is blue. Blue. All right, here we go. This one. When you have different number of x's on both sides, this one has 2x, this one has 1x. Another one with different number of x's is this one right here in disguise, because this has 3x plus 6, and then over here I have 0x plus 10. Any problem with different number of x's, as soon as I see on both sides of my equation that the number of x's are different, that makes that an instant one solution. So if I number this the way I've been numbering it, 1, 2, 3, 4, and then this bottom one 5, the way I've been numbering it, 1 and 3 for this combo is the one solution set. If I have the same number of x's on either side, but the numbers are a little bit different, that's the no solution look. So that one, number 2, a no solution look. If I look at number 5 and distribute that, that's a no solution look in disguise, because that has both has 4x, but one has a 12, one has a 10. That makes that a no solution. Same number of x's on both sides, but different number. Those are the no solution look. And of course, the last one here, if I combine like terms, or if I look at it and everything about it's the same, not only the x's, but also the number, everything's the same, that's a infinite solution. That one's going to go right here, number 5. Number 4. So again, here are the basics. If I have different number of x's on both sides, automatically a one solution. Something like that, something like this. Those both have x's on only one side, one solution. Of course, sometimes though, they might have you distribute and combine like terms first. The other one is if I have the same number of x's, but different y-intercept numbers. Those are your no solution parallel. Sometimes they give it to you straight up. Sometimes they have you distribute it to see that they have the same number but different y-intercepts. Those are the no solution. Same number of x's but different plane numbers. And of course, the many solution is when you have everything exactly the same, whether they give it to you straight up the same, or if you have to distribute it like this one to then see that it's exactly the same, or maybe even this one that you got to combine like terms for you to see if it's exactly the same. But again, if it's the same in every way, like that combination, that is a many solution, or infinite. That's a fancy word. Infinite solutions. All right, last problem, last word. Here we go. To solve this one, you're going to distribute this and then combine like terms. So remember, if I distribute, I get 6x minus 12, because 6 times negative 2 is minus 12, plus 2x equals 4. At this point, you want to combine that 6x and 2x together to get 8 of those x's. I've seen some people do the dreaded mistake where they do an inverse operation on the same side of an equal. That takes your equation that used to be balanced and really unbalances it, makes it drastically different. Really bad mistake. Let me try to show some of you the structurally what you're doing. It's almost like if I had 6 plus 3 plus 4, that's 9 plus 4. That's 13. That is a true equation. 6 plus 3 plus 4 is equal to 13. 9 plus 4 equal to 13. I could combine like terms together, and what that does is it doesn't affect my equation, keeps it still true. That's still a true equation. I could combine like terms together, and that doesn't change my equation. That's still true. That's still true. But what hacks up my equation is when I start to do inverse operations on the same side. Because watch, that would make this 2 plus 3 equal to 13, and there's no way that's true no more. So on this problem here, just make sure after you distribute, combine these together to get 8 of those x's. And then make sure you're not looking at the notes so much you start to use the problem in the notes. Right here, I'm going to add 12 to both sides. And that gives me 8x equals 16. Divide by 8, and that gives me my answer for x, which is 2. I need you to explain in words how you got this. I want you to say, I first distribute, then I combine like terms. So I'm looking for these words. First distribute. Then combine like terms. I want to see you write that right away. Then use inverse operations. Remember, you don't want to do any inverse operations until you distributed and combine like terms. For you explaining how you know, I want you to say that I plugged it in and checked it. But I want to see you take that answer, plug it in, and check it. So if I checked it, wherever there's an x, I'm going to put that 2, because that's my answer. Remember, everything stays as is. Even that 2 in front of that x stays the same. Only that x changes. That gives me 6 times 0, which some of you thought was 6. That is 0. So that is a true statement. 4 equals 4. That is true. So again, on that one, you had to say in words and then show me the math. Make sure your sentences have complete sentences. I think the other ones that you need to explain before I give you the last word is this one right here. Make sure you try to use complete sentences, reflect, then translate. And then where's the other one you're explaining? This one right here. Make sure you use complete sentences. Capitalize that first letter. Write a period on your last. Okay, the last word is green. Green. Write down all 5 of those words. Go back and listen again if you missed one. Good luck.